Welcome to the Aldol Condensation Lab. The aldol reaction is a carbonyl condensation reaction between two aldehydes or two ketones, giving a beta-hydroxyaldehyde or ketone, which will then dehydrate to give an alpha-beta unsaturated compound. So it's the reaction of an enolate nucleophile with a carbonyl electrophile. So this reaction can be used for both aldehydes and ketones. However, there are two types of aldol condensation reactions. One is the self-condensation reaction between two of the same aldehydes or ketones, and the second is a cross-aldol condensation reaction between two unique aldehydes or ketones. So it is the reaction of an enolate nucleophile with a carbonyl electrophile. So here you see this ketone, and it has an alpha carbon with 3 alpha hydrogens. These alpha hydrogens are acidic, which in the presence of base will deprotonate to give the enolate, which will then react with the carbonyl electrophile at the carbonyl carbon, which is partially positive. So this lab specifically is in a crossed aldol condensation reaction between acetone and benzaldehyde. So it's 5 general steps. The first step is the generation of the enolate. So acetone will react with sodium hydroxide to deprotonate to give the acetone enolate molecule, which is the carbon nucleophile in this reaction. The second step is the addition of the acetone enolate to the carbonyl electrophile benzaldehyde to give you this alkoxide anion, which will then be protonated by ethanol, the solvent, to give the beta-hydroxyketone addition product. Then this will undergo condensation in the presence of hydroxide to deprotonate this other alpha hydrogen to create a double bond and kick off hydroxide to give you the alpha-beta unsaturated ketone, which is the aldol condensation product. However, acetone has another alpha carbon to undergo a second aldol condensation reaction. So the fourth step is the second addition of the enolate. So here you're generating the enolate once again and then reacting it with the carbonyl electrophile benzaldehyde one more time to give the alkoxide, which will then be protonated by ethanol to give you the beta-hydroxyketone product, and then it is the condensation product to give you the aldol condensation product on both sides of the acetone molecule. The procedure for this reaction is to first prepare an ice bath. The second step is to generate the enolate. So you're going to add 12 milliliters of ethanol and 5 milliliters of sodium hydroxide to an Erlenmeyer flask. And then you're going to collect your test tube with 500 microliters of benzaldehyde and 200 microliters of acetone. And then you're going to slowly add the benzaldehyde acetone mixture to the ethanol. You're adding dropwise at this step to decrease the amount of byproducts and to increase the amount of desired products. Because acetone has 2 alpha hydrogens and there's the potential for a self-condensation reaction, there is a high chance of byproducts for this reaction, so we're trying to decrease those as much as possible by adding dropwise. The fifth step is to allow the reaction mixture to stir for 30 minutes. And then you're going to place your reaction flask into an ice bath for 10 minutes to let as much solid form as possible. And then you're going to collect your crude product via vacuum filtration. Make sure to wash your product with cold ethanol. And then you're going to weigh your crude product and transfer your crude to an Erlenmeyer flask for recrystallization. For this procedure, we're going to be doing recrystallization in ethanol. So you're going to put your impure solid in the Erlenmeyer flask, add 3 milliliters of ethanol. You're going to heat until it's a clear solution, and then you're going to cool it in an ice bath, and then you're going to do another vacuum filtration to get your desired compound over your impurities or byproducts. Then after the reaction's finished, you're going to do characterization. So confirm your product by analyzing the melting point and then calculate percent yield. So percent yield is the mass or moles of your pure product divided by the theoretical max mass or max moles of your product. So you calculate theoretical yield based on the limiting reagent. So first you have to identify the limiting reagent. If it's acetone or benzaldehyde, remember that 2 molecules of benzaldehyde reacts with 1 molecule of acetone. Then after you're finished with the lab, you're going to dispose of your product in solid waste, pour any remaining organic solvents into organic waste, and aqueous extract into aqueous waste. Remember to not mix organic waste with aqueous waste.